Day 2, Unit 6, Day 2. The saga continues, and my glasses are disgusting. Hopefully you can't see this. Are you enjoying the beard? Oh yeah, I can't grow a beard. Anyway, this is Mr. Key coming to you live from my basement. Oh yeah, someday I'll show you my basement. You don't want to see it. It's kind of grow disgusting. At any rate, I'm just kidding. Why am I saying that? Ooh, too much coffee. It's getting cold. Anyway, we're on day 2. If you haven't hit subscribe, hit subscribe. If you're borrowing my videos because, well, you simply just don't know what the heck you're doing as far as a teacher goes, that's okay. I'm cool with that. I got a lot of help from my friends too. But you might want to hit that little donate button. I need a new computer. I'm in the market. I'm looking. Starting to do some serious looking. Still don't have any money. Thanks, burgers. Still waiting for a little donation from you. Anyway, let's talk. What is this? What is this? Oh, this is multiplication. So when we multiply, we simply add the exponents, correct? A little warm up. This would be x to the 2, or we subtract the exponents. And when we have an exponent raised to an exponent, we multiply the exponents. Well, that's going to come into play when I come back to these things over here. But let's talk about this problem. See, up until today, well, let's try to find this inverse. So you know, in order to find an inverse, we switch x and y. So we end up with x equals 3 to the y. Now our job is to eventually end up with y equals something. Okay, can I divide? No, it's an exponent. So how then am I going to get rid of a variable as an exponent? I don't know how to do that. I'm lost. I'm like, okay, divide, multiply, take the negative, reciprocal, quadratic, blah, 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 blah. No, don't have any tools yet. Don't know nothing. And then all of a sudden we got this thing right here. Well, let's just find the inverse of that. We get x equals log y. Well, I don't want to do that, Mr. Krause. You just divide by the word log. Oh, yeah? Tell me what the word log actually means. You don't know. That's like dividing by sine. Huh? Or cosine. Let me divide by a little tangent. You can't divide by a word. Why don't I divide by the log? Huh? We can just divide by the. That's a good idea. The log. We'll divide by that. No, you can't divide by words. You can use words to hurt people, but you can't divide by words. So I got to come up with a way to solve this and solve this. And they sort of go hand in hand. So we're going to learn how to change the form. Change the form. So let's say I was to be nice to you and I was to give you 2 cubed. And I said, what is 2 cubed equal to? And you'd say, okay, that's equal to 8. Well, I'm going to tell you that I could solve this using a logarithmic, or I could show you using logs as well, where 2 is the base, the 3 is the exponent, and on the right side, this is just the number. We'll call this Ben. Ben. We're going to change the form using Ben. So what we're going to do is, again, the base is the base. And if I'm writing the word logs, and we talked about this yesterday, logs, the base goes down here, okay? And it's going to equal something. So we change the base by rewriting it as log base 2, and then these two things simply just switch their location. Log base 2 of 8 is equal to 3. Now, if I went over to my calculator and I go control log, now, oops, I got to go into calculator mode, and I go control log, first thing I'm going to do is log base 2 of 8. And you should see that that is indeed equal to 3. And I should be able to go back and forth. This is the base. This is the exponent. And this is what it's equal to. So these two things, when I'm changing form, change location. So in this case, it would be 2 cubed is equal to 8. We can go back and forth. So in general then, general, what we have here is base to an exponent is equal to n, transforming to log, don't change the base, that stays the base, but the other two things switch locations. Log base b of n is equal to the exponent. And that's how we'd go through and solve this one right here. If I wanted to solve this one, I would change the form. And we want to change the form anytime our variable is an exponent, and I need to get a hold of it. I need to get a hold of this y here. So what I'm going to do is I'm going to change the form. This is the base. This is the exponent. This is what, so I'm going to change it. So log base 3 of x is equal to y. And those are inverses of each other. Now, some of you are saying to yourself, prove it to me, Mr. Krause. Prove it. I know that inverses are reflections over the line y equals x, so you should be able to prove that to me. Oh, okay, I will. And you'll like this. So let me graph y equals, what was it, 3 to the x? 3 raised to the x. We know that's just a simple exponential function. And then we said its inverse was log base 3 of x. Let's see. If that's true, let me graph the line y equals x. Graph the line y equals x. Okay, there it is. So if it's true, my next thing I graph should be a reflection over that line. Control log base 3 of x. And you can simply see that they are, in fact, inverses of each other. Okay, so that's how we're going to use, that's how we're going to change our form, or change our form. Whenever the variable is an exponent, we're going to use this change of form idea. Okay. Oh, and in this case, one of the things you need to remember, and I think we talked about, hopefully we'll have talked about this the day before, if I remember correctly, that if the base is not given, then the base is 10. So in this case, this is, we keep the base, which is 10, and we switch these two. 10 to the x is equal to y. And again, if you don't believe me, we could graph that, but you believe me because you think I'm a genius. And I am, thank you. Base, what the heck did I want to say there? I don't know why I wrote the word base there. Maybe I'll come back to it. I don't even know. It doesn't matter. We're just going to change the form here. We're going to use our calculator to give us the answer, okay? So, see, my exponent is a variable. And up until now, I don't know how to solve that. I mean, I can just guess. 2. Well, it can't be 2 because 5 squared is 25, so that would be too much. And it can't be 1 because 5 to the 1 is 5. So it has to be somewhere between 1 and 2. I just don't know what it is. I mean, I can guess. I could just keep trying numbers until I get there. But I want to round it to the thousandths place. You're going to sit there and try to round until you get to the thousandths place to figure out what answer there. It was like 1.3. I'm guessing 1.35. So let's go. 5 raised to the 1.35. Oh, I didn't even hear. That's not even the thousandths place. Oh, I didn't put that in there. 5 raised to the 1.356. 8, not enough. 5 raised to the 1.489. What the heck? Oh, it's 55. Shoot. 5 raised to the 1.489. Ooh, getting closer. 5 raised to the 1.567. Ooh, too much. We could be here all day, right? This would be stupid, right? So, I mean, I can get there eventually, but it would be dumb. So what we'll do is we'll use change of face. This is the base, okay? So, and then these two are going to switch locations. So, log base 5 of 12 is equal to x. Oh, that's all I got to do. All I got to do is type in control log base 5 of 12. And it will tell me, oh, 1.4543. It's actually, we're going to round it the thousands places, 1.544. So if I go 5 raised to the 1.544, it should be around 12. There it is. Pretty doggone close. 1.544. All right, so here we go. This one should be obvious, right? This is just 4. Because I know 3 to the 4th is 81. But if I want to change the form, we're going to do log. The base remains 3, and then these two things change locations. 81 equals x. And then I can come over to my calculator. It would give me whatever. So, base. There's my base. Oh! It's all about that base. I'm going to pause this. Well, I was going to find that song for us on my phone, but then I decided, oh, we might get kicked off YouTube for that. So it's all about that base, all about that base. So when we're dealing with logarithms, it's all about that base. So in this case, we're going to keep the base, and we're going to switch these two. Now, you remember when we do this, we have to take the square root and put the plus or minus, correct? However, you can't have a negative base. So even though that would be the way to solve that, you're not allowed to have a negative base. Oh, man. Let's change this to a 2. So, hopefully I'll remember to do that. So, in this case, don't forget the base is 10. So, it's all about that base, Keep the 10. And we're going to switch these two. 10 squared is equal to x. So, what does x equal? 100. And again, if you don't believe me, you can just try it. Why am I clicking on the wrong thing? Log, and I'm not even going to put in the 10 of 100. It's equal to 2. See, it put it in for us. Remember, if it's not put in, if it's not there, it's understood to be there. Okay, so let's get moving. Let's figure out how to solve. Let's figure out how to get, find out what x is equal to. Okay. So, again, we want to get the weird thing alone. In this case, the weird thing clearly is this e, exponential base. So the first thing we got to do is divide by that 4. We got to get rid of that thing, 4. And now we've got e to the 3x equals 1/4. Now, this is a slightly different case. I still want to change this to a logarithms. And normally what I would do is I would change the form. Leave the base the same, log base e, and then these two things would switch. Of 1/4 is equal to 3x. But when we're dealing with e, we don't want to use log. We want to use its inverse function. And the log, the inverse function of e, a base e, is the natural log. And you have to use the natural log. Okay. So then we divide by 3. So that's just one thing you just have to be aware of. So when we change the base of that, we use e. So back and forth. The natural log of e. So, and again, just like with logs, I don't have to put in e as the base. They don't even give you a spot for it because the only thing the natural log works with is e. So e to the 1/4. All of this divided by 3. Make sure it comes out looking right. Yep, natural log of 1/4 is negative 0.462. Negative 0.462. All right, let's work on this. We got the weird thing all by itself, so we're going to take the natural log and we're going to change its base of e. And then these two things change place. 4 is equal to 2x. Divide by 2. Divide by 2. I come back to my calculator. I do natural log of e. Natural log base e of, I forgot what it was, 4, right? 4, all outside, divided by 2. And I get 0.693. X is equal to 0.693. Let me get this weird thing alone. E to the x, 3e to the x is equal to 2. Divide by 3, and I get e to the x is equal to 2/3. So we're going to change the base. The natural log of base comes down here of e to the x. But again, this is not necessary. You don't have to put it there. Is equal to, not of x, 2/3. Remember, those change place. Of 2/3 is equal to x. So I just do natural log. The natural log of 2 divided by 3. And you get 0.4054. X equals 0.405. By the way, when you're dealing with logarithms, you actually have to check your answer. And I wish I knew which ones of these didn't work. You should check your answers when you're dealing with logarithms. So like in this particular case, 4e to the 3x. So let me get hand ready. Excuse me. 4e. Now, I may not like that. I should probably have to put a times in there. Oops. I forgot to say what x was. What is x? Negative 0.462. So negative 0.462 stow x. Now remember, it's going to be a little bit off because I rounded. 1.02. And we had 1.000, right? So that's pretty close. So you do have to check these answers. Every once in a while you get a bogus or an extraneous solution that you just have to get rid of. We'll check. Divide by 3 here. We'll try a couple. Divide by 3 here. So this one's a little bit more normal. So now we have 2 to the x plus 6 is equal to 5. Since your variables in the exponents, we have to change the base, or we have to change the form. So we're going to use logarithms. Log. It's all about that base. About that base. Put the 2 down here, and then these two switch locations. Of 5 is equal to x plus 6. And of course, then we just subtract 6 from both sides. So log base 2 of 5, log base 2 of 5, and now don't forget the minus 6 has to be on the outside. Don't do anything silly. Negative 3.678. What happened? X equals negative 3.678. 3.678. Now I take that and stow it into x. I should be able to do 3 times 2 raised to the x plus 6. And it should be equal to, I believe, 5, right? I mean 15. And there it is, 15. Perfect. It works. You do need to check these. Sometimes it works, sometimes it does not work. Add 6 to both sides, so I get 3/4 e to the 3x equals 2. I hate that 4. I could have gotten rid of it right away. I'll get rid of it now. Multiply both sides by 4. So I get 3e to the 3x is equal to 8. Divide by 3. Divide by 3. And I get e to the 3x equals 8/3. Now we have to change the base because, or change the form because the exponent is a variable. All right, so what we're going to do is take the natural log of both sides. So natural log base comes down here, but we don't need this, remember, of 8/3 is equal to 3x, and then we divide by 3. So the natural log of 8 divided by 3, I believe, right? Yeah, so 0.327. X equals 0.327. This one's easy. But wait. Notice the base is missing. Remember, if the base is missing, there's really a 10 here. So we have a log function. We're going to change the form. So we go 10, and then these two things change place. 10 cubed is equal to x. So x is equal to 1,000. So base is 4, because it's all about that base, is equal to 3x divide by 3, and I get x equals, I have no idea, 4 raised to the 6th power, enter, divided by 3, was it? Doesn't go in evenly, clearly. 1365.3. 1365.3, repeating actually. Let's see, get the weird thing alone. So we get log of 7x is equal to 1. It's all about that base, So there's a really, don't forget, there's really a 10 sitting here. So 10 to the 1 is equal to 7x. These two things change place. Divide by 7, and I get x equals 10 over 7. That's good enough. All right, so get the weird thing alone, divide by 2, so I get log base 7 of 1 minus 2x is equal to 6, because we divided by 2. Now we're going to change the base, or we're going to change the form, 7 to the 6th power. These two things just change, is equal to 1 minus 2x. So this is 7 to the 6th. 7 raised to the 6th power, enter, minus 1, enter, divided by negative 2. So we get negative 58,000, so x equals negative 58,824. Now I'm going to check to see if that works. I'm going to stow that into x very quickly, and I'm just going to check that answer. So 2 log, now no base, base is 7, base 7 of 1 minus 2x. And we're hoping this turns out to be 12. It worked. Sweet. All right, so if you took a gander over to Wikipedia, you would find out that, let's go back up here because I forgot to, I wanted to come back to these ones. I want to teach you some logarithmic rules for expanding and, three basic logarithmic rules. One is the product rule. So for example, if you had log of x times y, that's equal to, or the same as the log of x plus log y. Notice we added. If you have division or a quotient rule, so for example, if I gave you log of x over y, this is equal to the log of x minus the log of y. Notice subtraction with division. And finally, if I gave you log of x to the y, otherwise we have an exponent, this conforms to, what do? We're going to multiply. It's a little bit weird. It becomes y times log of x. So those are your three expansion or condensing rules. So the condensed form is going to go up on top here. So if I gave you log, three rules, x times y, you should be able to pause this and tell me what that's equal to. If I gave you log of x divided by y, you should be able to pause this and tell me what the expanded form of this is. And if I gave you a log of x to the y, again, pause it and give me the expanded answer. This one, multiplication. So multiplication becomes addition. So log x plus log of y. Division becomes subtraction. So log of x minus log of y. Y, that's a y by the way. And this has become multiplication. This is multiplication. So log, so it's y times log of x. So all I want to do is expand. I think that's all I'm going to do. All I'm going to do is either expand or contract these. So if I gave you the expanded version, where they're all out there with adding and subtracting, we're going to convert it or condense it back. So I have multiplication here. So I want to expand this. So this is equal to the log base 3 of 3 plus the log base 3 of x, which is really equal to 1 plus log base 3 of x. Oh, I forgot. Do I have that definition up here? A logarithm is a number, is a logarithm. The logarithm is of a number is the exponent by which another fixed value, the base, has to be raised, and for that product to equal that number. Blah, blah, blah. Check this out. This is equal to an exponent that this thing has to be raised to get 3. So 3 raised to 1 equals 3. So that's why I said that was 1. You could always use your calculator. We're going to expand this. Now, the first thing I got to do is rewrite this. So this is the natural log of x, y to the 1/2 power. Wow, I don't know if we've talked about that yet. Hopefully by the time you get to this, I will have talked about the fact that the square root is the same as a 1/2 power. So what we're going to do then is use the product rule first. That's this one right here. So it's 1/2 times the natural log of x, y. Well, that's equal to 2 times the natural log of x plus the natural log of y. Or in other words, 2 natural log x plus 2 natural log y. Now, I'm not sure why I'm saying 2, so let me start this over and take my head out of my keister. It should be, I was right here, 1/2 the natural log of xy. But this can be expanded, so this is 1/2, not 2, the natural log of x plus the natural log of y, which would equal 1/2 natural log of x plus 1/2 natural log of y. All right, so we got a lot of things going on here. Here's the things you got to think about. Do I have an exponent? We're going to be multiplying. Do I have addition? Do I have multiplication? We're going to be adding. And do I have division? We're going to be subtracting. 3 things: add, subtract, and multiply. So we're going to have 2 in this one. We have an exponent and we have division. So first thing I'm going to do is rewrite this, getting rid of that division. Log of x squared minus the log, oh, I forgot the base, 2. Base 2 of 4. Now remember, this is equal to an exponent. It's equal to an exponent. So what exponent would I have to raise 2 to get 4? 2. So this is actually just 2. And then don't forget, this 2 goes out front. So this becomes 2 log base 2 of x. Oh, it's all about that base, Here we go again, kids. So this is log base 9 of 2x cubed minus, remember division, it turns into multiplication, log base 9 of 3. Well, we got a lot of work to do on this one. This one has log base 9 of 2 plus log base 9 of x cubed, but that cube goes here. Minus log base 9 of 3. We're just going to leave it like that. All right, so log, notice this one doesn't have a base, it's just base 10. So log of 2x minus log of 5. But this can be split up. So this is log base 2 plus log, not base 2, log of 2 plus log of x minus log of 5. So this is really the same as log of 5 times x to the 1/3 power. So I can rewrite this as log base 5 plus log base x to the 1/3, but exponents come out front. And there's what that's equal to. Now we're going to condense. We're going to work backwards. So if we have addition, it goes back to multiplication. If we have subtraction, it goes back to division. And any exponent goes back, any number that's being multiplied goes back and being an exponent. And I will tell you this, start with the multiplying first if you have it. So what I want to do is I want to look in front of each of the words log and see if there's a number. Is there a number in front of this log? Nope. This one? Nope. This one? Nope. Nothing. Okay, so there's no exponents. So I have addition and addition. So this is equal to log base 3 of, we got to do these in order, these two first. 4 times 2 plus log base 3 of 2. Well, this is just log base 3 of 8 plus log base 3 of 2. And since their bases are the same, let's do it again. This is just really log base 3 of 8 times 2, or log base 3 of 16. Now, there's a cool thing. We can check this. Let's just do log base 3 of 16. Get some stupid answer. And then we're going to do log base 3 of 4 plus log base 3 of 2 plus log base 3 of 3. And hopefully end up with that 2.5 thing. Oh, man, I screwed something up. So let's see if my multiplying is not right. 8 times 2 times 3. Oh, they're both 2's. Oh, they're both 2's. I said the last one was a 3, but they're both 2's. Sorry. This last one should be a 2. Whew. 2. And there's the 2.57, and there's the 2.5. There's the 2.5237. So they're equal. I just screwed that up. All right, so what we're going to do is we're going to take care of these first. Now, remember what I said. Look for an exponent. Exponents get returned first. See that 2? It has to get returned because it was an exponent. Now, I'm going to look at these two. It's subtraction. So, that's interesting. So this is equal to the natural log of x squared over 3 plus the natural log of 6. Okay, so that's got to go back to multiplication. So this is equal to the natural log of, really what we have here is x squared over 3 times 6, which is really equal to the natural log of 6x squared over 3, which is really just the natural log of 2x squared. Now I want to test that because I don't think that's right. Let me stow some value into x. 2.3 stow x. Oops, why am I not on here? 2.3 stow x. And then I'll do the natural log of 2x squared. Get some stupid number. Oh, the natural log of 2x squared. And then the original was 2 natural log x, so 2 times the natural log of x plus 3 and 6. The natural log of 3 plus, oops, plus the natural log of 3 plus the natural log of 2. Oh, 6. My goodness, I keep putting in numbers wrong. 6. Let me take a look. So I'm going to guess there's more than one of you that think I'm an idiot. So let me just make sure I do this right. All right, so let me, I think all I wasn't doing was typing in the calculator, right? So the original problem was, escape, 2 times the natural log of x minus, I think I had a plus there, the natural log of 3 plus the natural log of 6. Okay. And then we came up with the natural log of 2x squared. My goodness. I think I was just putting in a plus instead of a minus. How dumb is that? All right. I only got a couple left. We've got 3 left. 4 left. So, return exponents. 1/2. We also recall that x to the 1/2 is really equal to the square root of x. So this becomes log base 10, we don't need a base, of 3x to the 1/2 minus log of 5. Well, x to the 1/2 is x squared, and the subtraction comes back to division. So this is really equal to log of 3 square roots of x over 5. Return exponents, 3. And that's it. So this becomes log of x cubed times 4 minus log x minus log 6. Or in other words, this becomes log of 4x cubed over x. Now we're going to combine these two. Minus log of 6. Well, this is really 4x squared. So now we subtraction again. So it's log of 4x squared over 6, which is my final answer is log of 2x squared over 3. And I might check that. Of course, I might not. I might check it wrong. 3 log x plus log 4 minus log x minus log 6 minus log x minus log 6. They put a lot of tens in, right? And then I'm going to do log of 2x squared over 3. Hey, there it is. Got the right thing. All right, so you can see it's kind of a pain, but we're okay. 3 goes back. So this becomes log base 4 times x cubed plus log y. Again, it's addition, so we just multiply. So log 4x cubed y. Done. That was easy. 3 goes back. 2 goes back. That's it. So this ends up being the natural log of x plus 1 cubed over y squared plus the natural log of y plus the natural log of 2. So this becomes the natural log of x plus 1 cubed over y squared times y. So that y cancels one of those y's plus the natural log of 2. And then that becomes, hopefully my big head's not in the way, the natural log of x plus 1 cubed times 2 over y. Not going to bother to check that. I will probably type something in wrong. Anyway, we're going to keep practice with the condensing and contracting, condensing and expanding, condensing and expanding. We'll get used to it, okay? You'll get better at it. I know it's kind of weird, and it's kind of tricky, and it's got some new rules to get used to. That's why we're going to spend a few days on it. All right, kids, it's been fun, and it's been real. And hit the like and subscribe button, but it hasn't been real fun. Yes, it has. Bye. I don't think I hit the right button. Stop.